The winds on Neptune reach the speeds of 1,600 miles per hour. That's 3 times faster than a commercial airplane. Temperatures at the Moon's south pole reach minus 397 degrees Fahrenheit, which just might be the coldest in the entire solar system. Saturn is less dense than water, so if it were thrown into a giant pool, it would float. Jupiter's moon Europa is covered in a thick layer of ice, but underneath it is a vast ocean of water, measuring up to 100 miles deep. Water ice was previously thought to be rare and only common for Earth, but it can, in fact, be found all over the solar system, even on Mercury and the Moon. Saturn's magnificent rings are a belt of space debris that formed after one of its moons fell apart. Jupiter, Neptune, and Uranus also have rings, although not as splendidly as Saturn's, and even some asteroids have them too. There are 8 confirmed planets in the solar system, but evidence shows there can be a 9th, we just haven't discovered it yet. Organic matter could have been brought to Earth by comets, since it has been found on several of them. Saturn also has a never-ending storm, just like Jupiter, but it's also peculiar for its shape. It has 6 distinct sides. Mercury and Venus are the only planets in the solar system that have no known moons. Jupiter has 79 known moons orbiting it, the largest of which is Ganymede, and it's bigger than Mercury. It was thought that the Milky Way is a belt before, but now we know it's a spiral galaxy. Footprints on the Moon can't disappear, because there's no wind to blow them off the surface. There's a theoretical possibility of a white hole, the reverse of a black hole. Nothing can enter it from outside, but light and matter can escape from within it. Triton, a Neptune's moon, orbits the planet in a backwards motion. It's the only moon that does so, and nobody knows why. Although there are trillions of stars in space, we can only see a tiny fraction of them in the sky. Charon, Pluto's moon, is half the size of its planet, which is why Pluto orbits a bit around a spot outside its own axis. All the objects in space, including planets, interstellar dust, and whole galaxies, comprise just about 4% of the universe. The rest is dark matter and dark energy that can't be seen and isn't fully understood. TRES-2b is a planet where night never ends. And it's not your regular night with stars shining in the beautiful skies. Here it's pitch dark and scorching hot. TRES-2b is a gas giant, roughly 1.5 times more massive than Jupiter, and its surface absorbs light better than charcoal. It might also have a faint dark red glow because of its burning air, which is as hot as fresh lava. Lovely. In the star system of 55 Cancri, there are 5 planets, 4 of which are gas giants similar to Jupiter and Saturn. But the 5th one, or rather the first because it's closest to the star, is different in a most horrible way. 55 Cancri e is so close to its sun that half the planet's surface is a literal ocean of molten lava. The other half is in eternal darkness because it never sees the sun. The planet is always turned to its star on one side, and between the scorching and the dark, there's the twilight zone, a thin strip of gloomy nothingness. HD 189377b, I'm not going to say that again, is the only exoplanet in the orbit of its star, and at first glance it looks quite pretty, blue and white swirls making up wondrous patterns on the surface. But these pleasant colors actually come from hard silicate particles in the planet's atmosphere, which means it rains glass here. But the worst is that winds reach the speed of 5,400 miles per hour, or almost Mach 7. Well, for comparison, the fastest wind speed on Earth was 254 miles per hour, over 20 times less. Thus, the glass falling from the sky travels horizontally at hypersonic speeds, shredding everything in its path. The next system, whose name I won't even try to pronounce, this one, has 3 exoplanets, which are all being slowly destroyed by their own star. It happens because that star is not a regular. It's a pulsar, a rapidly spinning core of an exploded star. It creates powerful electromagnetic pulses in several directions while rotating at several thousand times per second. As a result, the planets orbiting this deceased star are slowly being eaten away and will eventually disappear entirely. Kepler-70 is a hot blue dwarf star that exploded into a red giant some 18 million years ago. At the time, it was orbited by at least 2 planets, the closer of which was a Jupiter-like gas giant. Its name was Kepler-70b, and it still exists, but the overgrown star consumed it and transformed it into a blazing hot rocky world. Right now, it's one of the hottest planets ever discovered. Its temperature is higher than the surface of our Sun. It was lucky to survive spending time inside the star, but it's evaporating now and will probably be no more in the near future. There are 6 Mars exploration missions on or around the red planet at the moment. Does that mean that Mars is inhabited by robots? The little green men aren't saying. If the Sun was the size of a front door, our planet would be the size of a nickel. In other words, the Sun could fit more than 1 million Earths. Moon rocks have a super slow erosion rate, about 0.04 inches for every 1 million years. That's why the Apollo astronauts' footprints left on the Moon are likely to stay there for 10 to 100 million years. Jupiter's moon, Io, is 4.5 billion years old, almost as old as the planet itself. It's one of the very few bodies in the solar system with active volcanoes. And these volcanoes are powerful enough to produce spectacular views that are later captured by Earth's telescopes. Oh, by the way, Io is named after a legendary maiden who was loved by the Greek god Zeus. In the myth, Zeus turned her into a heifer in an attempt to hide her from his jealous wife Hera. Wow, so the cow did jump over the moon? Oh, I think we could use some more cowbell. Okay, enough of the cows. Back to space. A neutron star gets born after a supernova collapses. After birth, it rotates extremely fast, about 60 times per second. But this rate can sometimes grow up to 600 times per second. Makes me dizzy. Space isn't supposed to be black. There are stars everywhere. Shouldn't they light everything up around? You don't see stars wherever you look because some of them haven't existed long enough for their light to reach Earth. Another one of Saturn's moons, Iapetus, has a unique two-tone coloring. The difference between the satellite's 2 hemispheres is impressive. One of them is light and the other is eerily dark. Scientists haven't figured out this mystery yet. All of the planets of the solar system would fit between Earth and the Moon with some space left. Yes, there's lots of space in space. Saturn isn't the only planet that has rings. Gas giants Uranus, Neptune, and Jupiter have rings of their own, but they are thin and almost impossible to see. NASA can convert plasma waves, radio waves, and magnetic fields into audio tracks and listen to what's happening in space. They record all kinds of intriguing sounds, from beeps to ambulance-like howls. At the same time, space itself is an eerily silent place. There are some sound waves and vibrations, but people can't perceive them. The star's core takes up to 25% of its entire radius. Inside, gravitational forces create incredible temperatures and pressure, which makes hydrogen fuse into helium. This layer has a temperature of 27 million degrees Fahrenheit, give or take. All that energy moves to a zone called radiative. It takes on average 170,000 years for the energy to get all the way from the core to the next convective zone. There, bubbles of hot plasma float upward and end up at the sun's surface. That's where a visible 300-mile-thick layer starts. This gassy zone, and don't I know about gas, is called the photosphere. It gets heated to 10,000 degrees and consists of granules, cells of plasma 600 miles in diameter each. Moving further, we get to the crown. That's the star's thin atmosphere. It's getting hotter again, with temperatures reaching 3.5 million degrees, so we'd better not linger. The smallest of all the 4 inner planets, Mercury is just 3,000 miles at the equator. It's also the second densest planet, topped only by Earth. Mercury has a massive metallic core. It takes up almost 85% of the planet's volume. Its core contains more iron than any other planet of the solar system. Recently, it's been discovered Mercury might have a solid inner core, along with its outer core that consists of liquid metal. The planet's outer shell is composed of a rocky mantle and solid crust, which is just 250 miles thick. Mercury is too small to hold onto its atmosphere, made up of hydrogen and helium. The planet is also too close to the Sun. That's why the solar winds keep sweeping away the little atmosphere the planet manages to gather. Our next stop is the hottest planet in the solar system, with average temperatures reaching 870 degrees Fahrenheit. It means lead would melt if you brought it to Venus. The pressure on the planet's surface is the same as at a depth of 3,000 feet underwater on Earth. The planet's metallic iron core is 2,400 miles wide, which is almost as the distance from New York to Los Angeles. The next layer is a molten rocky mantle that's 1,200 miles thick. Venus's insides are covered with a crust. It consists mostly of basalt and is 6 to 12 miles wide. The planet's thick atmosphere is nightmarish. It's 96% of carbon dioxide with 3% of nitrogen and thick clouds of sulfuric acid. Now, on Earth, people are used to a beautiful sunset that's painted in hues of orange, red, and yellow. On Mars, however, the normally pinkish-red sky turns blue as the sun goes down under the horizon. It's because Mars is much farther away from the Sun than Earth, making the sunlight less intense. The fine dust in the Martian atmosphere absorbs the blue light and gets rid of the warmer colors that you typically see on Earth. Whether it's blue or yellow, both sunsets look spectacular. Humans have been exploring space for over 60 years, and the effort has certainly paid off. All the planets in our solar system have now been explored, even the dwarf planets of Pluto and Ceres. Most of the exploration was done by NASA's Voyager program, which began in 1977. Voyager 1 and 2 collected information on the planets, their moons, and their unique system of rings and magnetic fields. These twin spacecraft continue to send data back to Earth, and Voyager 1 is currently in interstellar space. In 2011, astronomers discovered an enormous water reservoir simply floating in space around a supermassive black hole called a quasar. Floating water vapors have been found throughout the universe, but they aren't that common. This particular reservoir holds around 140 trillion times the amount of water in Earth's oceans. It's one of the oldest, largest, and at more than 12 billion light-years away, it's the farthest known to humankind. On Earth, sound waves make air molecules vibrate, which is why we're able to hear sound. Other planets and moons allow sound to travel through mediums like their atmospheres and oceans too. In space, though, it's said that there is no sound, since there aren't any molecules to vibrate and deliver sound waves. However, not all researchers agree on this, given that space isn't just a desolate vacuum. In between the emptiness, there are clouds of gas and other stray particles. So, depending on where you are, sound waves can be possible. Discovered in 2017, Kelt 9b is the hottest planet we know of. Next time you're complaining about the heat on a scorching summer day, just remember that temperatures on this planet can reach 7,800 degrees Fahrenheit. That's because Kelt 9b orbits really close to its star, which is called Kelt 9. This thing is way hotter and bigger than our Sun. Experts believe that the giant star might someday evaporate the entire planet with its intense heat. Kind of a sizzling solar sauna, wouldn't you say? You wouldn't? Okay. One moon day is equal to about 29 days on Earth. It takes that long for the sun to cross the lunar sky. People always see the same side of the moon. The Earth's gravitational field makes the moon spin around its axis slower, That's why it takes the Moon the same time to rotate around its axis as to orbit around the Earth. It was only in 1959 that people could finally see the other side of the Moon, thanks to a photo taken by the Russian spacecraft Luna 3. The other side of the Moon is more mountainous than the one we see from Earth. It can be explained by the Earth's gravity, which made the crust on the visible side of the Moon thinner. Craters on the Moon were left by asteroids 4.1 to 3.8 billion years ago. They're still visible only because geological changes on the Moon aren't as active as on Earth.